So good morning to all. I will start discussing about the continuation of the topic which we had on previous session is the DNS, domain name service or domain name server. To do this service, a domain name service, if arrangement is being maintained, that's called a server, DNS. So hope everyone have understood about this content of domain name. So with this understanding, we will proceed for the next level of part of the DNS. DNS caching and updating records. How the DNS caching is happening. Already we discussed about what is the meaning of caching. Some transaction between a client and server. If it is happened, some portion about how the server has responded, the server will give some unique ID for that particular client. That information will be retained in our local system. Every time the server need not to do a verification or need not to establish the new connectivity like that. Already we discussed in the cache. So the same arrangement, if it is implemented for a case of DNS, how to do? So the cache entries, a timeout, that is a provision is called time to live cache entries. That means how much duration that the device can have, it can maintain the information about that, that's called time to live, TTL. The TLD servers typically cached in a local name server. Local name server is nothing but, for example, now from today onwards, we are inside a college campus. When currently I'm accessing the college network. So this network, I am connecting with all of you through our college IP address. So our college IP address, it's a unique static IP address which already we discussed. That is the unique information which will communicate with myself and with all of you. So for that particular IP address, for a communication perspective, from node to the node, multiple nodes, the IP address is enough. But in the perspective of if I want to connect with some browser, browsing some web applications or web pages, so I need to connect with through our college DNS server. There are DNS server is available in our college campus. If I am accessing everything, all transactions will go through that DNS server. So DNS server will maintain a certain cache information over there. So that's the point which I was talking here. Okay, with this I will proceed because we need to discuss a lot about it. So DNS, distributed database storing resource records. Resource record RR. That format of RR look like this: name, value, type, and TTL. Type A means name is a host name, value is IP address. If it is a type A, if the type is equal to, if type is equal to A, name is a host name, value is IP address. If type is equal to NS, then name is domain. Example, something, foo.com. Value is a host name of the authoritative name server. This is called a name server. Yes. Am I audible to everyone? Yes, there was some network issue here inside a campus. Now I have connected through my mobile network. Hope my voice is clear to everyone.
Yes, sir.
Okay, thank you. So now I am sharing the screen once again. So we were discussing here CNAME. So the meaning of a CNAME, if wherever you see the type here, if it is written as a CNAME is a alias name. If amrita.edu, with the same amrita.edu, if by giving some other website, amritavishwavidyapidam.edu, somebody is typing something like that, still if it is pointing that same domain name. So one same particular website can have a multiple addresses like that. So that's maybe another point of a aliasing name. So MX values a name of a mail server. This is called mail server associated with the name. So these are all the information about the DNS RR record. DNS protocol messages. So how the protocol content will look like this. You see, query and reply messages, both with the name message format. You see here, if you take a message format, 2 bytes, 16 bits, 2 bytes, another 16 bits, totally 32 bits. Assume that 32-bit width one data is available. In that, the lower order 13 bits, it talks about the flags. What are the types of flags? Query or reply. Is it a query type or reply type? Recursion desired, recursion available, reply is authoritative or not. That information will be flagged off. Okay. From that, we can easily understand. What is the identification? The identification is a 16-bit number for a query. Reply to the query uses the same number. So that's the meaning of that. And the next 16-bit will have a question. What is a question? Answer will be here. Authority RR, additional RRs, questions, variable of the questions, different types of questions, answers, different answers. Like the total, a bundle of a DNS protocol message will be like this. So this is a template. We need not to go in depth on this part. Just you have an idea. Okay, this is the way how the data packet is communicated from one point to the another point. Then, so then name and type of fields, RRs in response to query, that already I have discussed. So we'll move on to the next one. Inserting records into DNS. Now, through, as per our earlier discussion, GoDaddy. Yeah, GoDaddy. Through the GoDaddy, if somebody wants to get a new website, the GoDaddy has the authority to create a domain name. If the domain name is called something like that, Network Utopia, if somebody wants to create. So what will happen? So register the name networkutopia.com at DNS registrar. There is a registrar. Provide names. It will be stored in the format like this. So TLD means a top level domain server, top level domain server. So registrar inserts the 2 RRs into the .com server. What are that information? This is first information. Networkutopia.com is the name. DNS1.networkutopia.com. DNS1 means it's a .com site. And NS. The type is NS. And DNS1. networkutopia.com / what is the IP address, comma A. So the meaning of A and NS, which we discussed now, A means is a host name. NS means actually it talks about the domain name. So that part we can see here. We can see this is NS means domain name. A is actually is called is the corresponding IP address, that information. So create the authoritative server type A record. or it is creating authoritative server type for this particular website, and type mx record for the network-utopia.com. So it will create all the required information to the specified DNS part. That's all. Yeah. Now another important point is called attacking DNS. DDoS, distributed denial of service. What is the meaning of this? Attacking DNS. The first point, bombard root servers with the traffic. What is the meaning? Whether meaningful communication is there or not, from the multiple clients will start asking something later towards to that particular. This is called a virus program. We can say in that fashion. Whether it is meaningful or not, to make sure that that server should not function properly, one particular website or in a different location keep on requesting something from through a web browser, means what will happen? The server has to respond for that. So that's called bombarding the root servers with the traffic. So the server cannot function for a real request. So for that, the denial of service, before the server start responding, some sort of a filtering should be there, whether the request is coming from the authorized person or not. Accordingly, it has to respond. So not successful to date. If it is not successful date, traffic filtering can be used. Local DNS server cache IPs of TLD servers, allowing the root cache bypass. So we can go for a multiple strategy for maintaining that. Bombard TLD servers, potentially more dangerous. It's actually which will some of the times, because currently many of the filtering tools are available, but some virus program which is loaded in our browser, we have to be very cautious in that. Sometimes we may experience that we may not be typing certain web page or something, so automatically it will type something on the browser, and then it will start sending a request from our mobile phone. Things may happen. So to avoid this type of situations, what we supposed to do in our system, better we can have some reasonable good I hope I'm audible to you, all of you. Yes. So, so this is called redirect attacks. So things are happening automatically if some virus program is doing all those things. So man in middle. So sometimes as a human being, we have to interact with the system. Then we have to monitor that whether things are going or not in proper way or not. We have to check that. So the next one is DNS poisoning, and the same send a bogus relays to DNS server which caches. So it's a bogus. So due to the virus programs, we can write. We can also write our own virus program for that. But ethically speaking, we should not do that. But for learning purpose, how to do that, we can test on that. But normally there are some filters available in the servers. That server will check with the authority of the source from where it comes and all those. It is exploiting the DNS for DDoS. Send queries with a spoofed source address, target IPs. So actually the source may not be available, but it will assume that it will, yes, there is a source available. From there, actually it is sending the request like that. That type of environment can be created. So this is called attacking DNS. So with this, the DNS part is over. Now the next important part which we are going to discuss, which normally we may not be discussing much in our regular sessions. Peer-to-peer applications, P2P. The concept is from up to now what we have discussed, the keyword client and server. A server is listening, the client is actually sending a request, there is a response like that. So now the totally the a different scenario, P2P applications. No always on server, pure P2P architecture. The example for P2P architecture, anyone can tell about that? BitTorrent, the examples here is given now, BitTorrent. And another the streaming, Concon and Skype. The Skype is also the streaming application which is coming under peer-to-peer, the sense that point-to-point or peer-to-peer. One source to the another source directly. There won't be any the server concept. The server is continuously listening like that. It won't be like that. Anybody knows about how the BitTorrent works? How the torrents websites are working? Yes, Kishore? You are not audible. Hello? Hello? Mr. Kishore, your voice is not audible for me.
Hello, can you hear me now, sir?
Yeah, now it is okay. Yes, please.
Sir, instead of relying on a server, we rely on other users which access the same file. So we get the data from other users.
We give the data to others or we receive the data from others?
Both, sir, in both way to use.
So it's like a win-win strategy. If you want to give to somebody else, if you want to get from some data from somebody else, you also have to be ready to give some data to others. Yes, am I correct?
Yes, sir.
Yeah. Okay. So any of the applications, have you done the installation on your system? Anybody?
Like everyone has. Sir.
Everybody have the that application with you, is it?
Yes,
Almost.
sir.
Yeah. Good. So the especially the MuTorrent, BitTorrent, all these applications are running on this the peer-to-peer architecture. So we started our discussion. There are two major architectures are there, especially in networking. One is called the client server architecture. This is the second one is the P2P, peer-to-peer architectures. So today we will discuss about that. No always on server. Arbitrary end systems directly communicate. End system will directly communicate to the node to node. Peers are intermittently connected and change the IP address. Some of the peers they may connect, they may interconnect with the other one like that. I'll give some example for that. File distribution in client server versus P2P. How much time to distribute a file from one server to n peers? So this is a one simple calculation we will discuss about. A peer upload or download capacity is limited resource. Okay. If you take one file size, a server upload capacity US, servers upload capacity. File size is equal to F. UN, a node's upload capacity, a node's download capacity. Hope you might have seen that what is the current state of uploading and downloading capacity of a system. U1, D1. Like that, user 1, this is node 1, upload and download capacity. Node 2, upload and download capacity. Like n number of users are there here, assume. DI, peer I download capacity and all those. So, when all these devices are connected together, Depends on the uploading and downloading capacity available on the node. The overall the time computations can be done, how much time it will take to upload your data to a server or download the data from the server. Data means the data file. That can be calculated. File distribution time in the client server. As per the discussion which we had earlier in the previous slide, the server transmission must sequentially upload the n file copies. Time to send one copy, capital F divided by US, because it is sending with the rate of upload capacity, US. Time to send for n copies, because if n members they are asking the same content, means it has to send n copies for n. So how much time it will take for what is capital F? Here is the file size. That file size is getting multiplied by US. US is nothing but server upload capacity per second. How much amount of the file data? 1 Mbps, 10 Mbps, something like that. So divided by that is, then we will get a in terms of time, in terms of seconds, unit in terms of seconds. For one system, F divided by US. Like that, for n copies, if the server wants to communicate n into F divided by US, that much amount of time the server will be occupied. This is from the server side. If you come to the client side, each client must download a file copy. So this is now up to now what we discussed. It's based on the uploading capacity of the server. Now, how the client can access that same information? The server may have a good capacity and a good uploading capacity, because bandwidth may be higher. Here the channel capacity may be good, but this client need not to have the same thing. Normally it will be lesser than. So the dmin, minimum client download rate, dmin. Minimum client download time is equal to F divided by dmin. Time to distribute. F means a file to n clients using the client server approach. CS means client server. So the time, this is the time. How much time actually take? N into F divided by US, because it is actually uploading time for n users. Server is uploading, how much amount of time it will take? That. And D divided by dmin, how much amount of time each client can take to receive that file? Among these two, which is maximum? That time is actually is the time duration for a client server communication. This is a way we can calculate this. So it is decided based on the client server, the channel capacity, how much as per the dmin, no, which we discussed, uploading and downloading capacity, that is going to decide that. So increase linearly in n. So this parameters, which the F, the increases linearly in n. So we can see the another parameters, file distribution time in P2P. The server transmission must upload at least one copy. So one copy, time to send for one copy is equal to F divided by US. Only one copy has to be communicated to one particular node. Client, each client must download a file copy. Minimum client download time, that already we know, F divided by dmin. Clients as aggregate must download n F bits. Maximum upload rate, which we have assumed, is US plus summation of UI. Because each client has to act as the peer-to-peer, no? When one copy is being taken from the server, it's being maintained over here assume that from there it is going to provide the information to other person if anybody wants to access the data. Now the load of the server is actually reduced. Now it is the copy of the same information is going to be retained in either this system, this system, this system after some time. So hereafter the overall upload rate we can visualize like that is US from the server's side upload rate, summation of all UI, individual upload rate for each system. So time to distribute F to N clients using P2P approach. Now we are comparing P2P approach. So what is the maximum duration? You see here, this is F divided by US 1, F divided by D min, which already we discussed in the previous also, these two. But in the client server approach, N clients for N devices, devices, the server has to communicate. But in here, only for one computer, the server has to communicate. From there, it is like an in the examination hall, sometimes the invigilator, they may come, they may have the bundle of papers. Sometimes some teachers, they may come and distribute the paper to go to each and students, every student's location, and they will distribute the paper. That's called a client server approach. The another approach, they may come to one front row, they will keep the 10 papers in front of the first table, first student who is attending, writing the exam. He will take one paper and he will pass the information to the next one, like that. So that may be the another example we can, some analogy we can take it for a peer-to-peer. So then N, F divided by the total time. So among this, which is the maximum duration, that is that much amount of time it will take. Now we are going to see these two increases, it's linearly in N. Okay, we'll see that. But as each peer brings the service capacity, we'll see this very important point here. The client upload rate U, F divided by U is equal to, assume for 1 hour, US, the server upload rate is equal to 10 U, D min greater than or equal to US. For this particular configuration, the minimum distribution time, capital D, for client server, if you go for N is equal to 5 users, assume that this is for N 5 users. If the client server strategy, if you want to follow, if we are following the, for a limited number of clients, we may not get experience, like up to 5 clients, 5 users, 5 nodes. Almost these two are looking like the same performance. But when you go for a huge number of communication from the client to server, you see here, the client server strategy is following the linear approach. That's the point which is discussed over there, N. But here in the P2P, because since it is being distributed, it is actually the amount of time, distribution time is actually reducing like anything. With respect to this, if you see for a case of the 30 users for N node, number of 30 nodes is getting data file from the server. If we follow client server approach, 3 units of time it will take, but if you go here with P2P, approximately 0.75 units of time, we can, how much time can be saved for a distribution of the file. This is also the another strategy of the big data analytics, like the distributed file system. This logic actually is being used there in the distributed file system. But there are also the blend of both client server and distributed file systems will be there in this. P2P file distribution, especially in a BitTorrent, file divided into 256 KB of chunks. So the total file is being divided into 256 KB chunks. If it's a 100 MB file, 256 KB, 256 KB like things will be divided. peers in torrent send and receive these file chunks. So it won't receive the files as a bulk. Instead, it will transmit a portion of the bigger file. So the application which we have done installation on our system, like MuTorrent, or these are all the application. That application, if you open, there you can see. Just a minute. There is a provision in the. I have used some other application. I forget the name of that. We can control the uploading capacity and downloading capacity of our system, because our resource is going to be utilized by for the peer-to-peer communication purpose. So we can control through that application. So how that application actually is running. So what I am asking all of you is that all of you can try to share the file, develop your own one small file. Assume that some of the video or some of the text information or book information or any other meaningful content, if you want to share, you create one valid application. From there, you start sharing to other all class members. Are you getting or not? How it works? Then you can experience that. Okay, this is all about file divided into how it happens inside. 256 KB chunks peers into your torrent to send and receive file chunks. So how it happens? I will explain this. Tracker, there is a concept called tracker. Tracks the peers participating in torrent. Who are all the members are currently live into the mode of ready to share the content. So the tracker is the module, a software code which will track how many users are currently available in the web in a network, who is ready to provide what type of files, like that. So it will be maintained, and the arrays obtains the list of the peers from the tracker. So from there begins the exchange of file chunks from the peers. So at one day, morning 9 to 10, out of 100 nodes, only the 10 nodes may be having they are ready to provide the access of the file. So after some times, they may go to in off mode. They may not be available. But the same amount of file what they had, some other remaining systems also may have. So what will happen? Once these people got disconnected from there, immediately the communication will be established because of the tracker will continuously keep on update that if these people got disconnected, immediately it will establish a connection to this particular peer to receive the data. So this is the way things are happening. So okay, BitTorrent. Alice optimistically unchokes the Bob. Alice becomes the one of the Bob's top 4 providers of the Bob reciprocates. So already, which I have explained, already all you people have experience with that. Just it is explained here in graphically. Highest upload rate. Among that, you can see that there is some green symbol or percentage wise which particular user they are seeder. Actually, I think they used to seed who is ready to provide more bandwidth. Accordingly, they will do some sort of ratings. That based on that we can decide which particular from which client we want to download a file. That is also can be possible. So with this, I will move on to the next topic. Do we have time now? Yes. Yeah. CDN. Okay. So for today, I'm stopping here. Uh, so hope you understood about the concept of DNS and P2P. The CDN, actually, if I am starting, then I need a complete